I would like to welcome everybody to today's presentation on lessons learned on the I-93 corridor. My name is Jay Levine, and I was the I-93 corridor supervisor. And today I will be assisted by Wendy Johnson, who is the project manager for the I-93 projects. Today we will go over a brief history of the I-93 expansion from start to finish and transition into some of the lessons learned that we had along the corridor. The department's early efforts to construct the four-lane widening was met with opposition and ended up ultimately in the courts. But coming out of the litigation, the department was allowed to adopt the three-lane alternative build for the 20-mile stretch from the Massachusetts state line to the Manchester 293 split. With that in mind, the department constructed all the projects assuming that someday the fourth lane would be built. Therefore, all our embankments, drainage, and bridges were to accommodate the future fourth lane, with the understanding, hopefully, prior to the finishing of the overall construction of I-93, that the fourth lane would be approved. Also, part of the project, we were going to reconstruct all 5 interchanges from the state line to Manchester. Essentially, they were to be reconstructed from start to finish. The work included 45 bridges, 23 which were new, and 20 that were considered red listed. Park and rides and sound walls, as you would expect, were also part of our mitigation package. The I-93 widening was originally added to the 10-year plan in 1986. By 2004, the final environmental impact study was published and looked at 7 potential builds in all. Ultimately, the department adopted the 4-lane configuration. Also in 2004, the EIS made several recommendations on behalf of the department. Some of them included construction of park and rides, expanded bus service, development of incident management procedures, ITS installations along the corridors such as message boards and cameras, provide for future rail service in all our embankments and bridge construction. Canby Lake and Cobbetts Pond received increased spill containment buffers. The use of salt brine with training for all maintenance personnel were part of the project. But my favorite recommendation was that the majority of the work was to occur during the daytime. All this sounded good, but the CLF took the department to court over population and growth estimates and its effects on air quality and traffic on secondary roads. The department worked with the CLF and other vested players and agreed on an interim 3-lane build until these issues could be resolved. Here is a look at the estimated cost of the project, 2020 versus 2010. Luckily, I have the PowerPoint presentation from back in my youth to be able to compare the costs. So with an original estimate of $794 million in 2010, I think we did pretty good, coming in at around $755 million, which translates to a $39 million savings. Other notable issues were right-of-way, which came in a little higher than expected. Engineering also came in higher than expected, but that is more related to the initial building 3 lanes and then switching to 4 lanes. Plus, there was a work stoppage on the design at one point, which led to renegotiated contracts and contributed to an increase on the engineering side. But construction efforts came through and underran by. Construction phasing along the corridor was broken up into 3 categories: early action, mainline priorities, and capacity improvements. Early action projects were things like park and rides, bus service, and things that would help commuter travel along the corridor and relieve congestion issues. The part I really liked were the mainline priorities. Constructing these was pretty rewarding. We took cloverleaf interchanges with poor acceleration and deceleration lanes, like the exit 2 and exit 3 interchanges, and reconfigured them into diamond interchanges, thus eliminating the traditional backups during commuter hours. Once these projects were finished around 2016-2017, we saw huge differences along the whole corridor in people's travel times. Even though we weren't in 3 lanes at that point in time, it certainly helped relieve a lot of congestion along the corridor. The final phase of the I-93 widening were the capacity improvements, which is what most of us have been working on for the past few years. This is when we were really able to open things up. The department had large projects ongoing to create the final 4-lane configuration. As of 2021, I can gladly say we are just about finished. We have the final contract to begin this spring, which is the inlay of pavement markings along the 20-mile stretch. As of 2017, the department completed their mainline priorities and early action projects, $350 million. The everyday bottleneck conditions that existed between exit 2 and 3 southbound have been eliminated at this point, and traffic from exit 3 south is now flowing in 3 lanes. Other issues that we had at this point for mainline priorities and early action was always funding. So what you can see here is that the Garvey bonds played a major role as well as the ARA funding. But at this point, we are still looking for other funding streams to finish the project. The final phase of work along the corridor involves capacity improvements. department at this time was still struggling for a funding source, but was eventually funded through House Bill 367, which included a 4-cent gas tax. So construction continued from 2016 and ultimately finished in 2020 with the new funding stream. So now that you know the history of the widening of I-93, let's talk about the lessons learned from our experience. To come up with the lessons learned, I broke it up into 3 categories: traffic management strategies, environmental issues, and design considerations. A good starting point to discuss what worked and what didn't was pulled from our traffic management plan that was developed for the I-93 projects. Each year, we write a memo to the Traffic Control Committee speaking about the different strategies that worked and what didn't. So let's take a look. Traffic control and construction coordination meetings were expected to occur on a regular basis. In theory, this was a good idea if we operated in a more condensed project timeline. Because the projects were spread out over a longer timeline than originally planned, these meetings were only necessary when projects had overlapping traffic control phases. In some instances, the prime was the same on both projects, so it was less important. But on others, meetings between the primes helped, and in some instances, work was actually swapped to assist in the overall efforts. I-93 lane restrictions set forth in a contract were based on historical traffic counts taken prior to construction. Because of seasonal fluctuations occur with our traffic numbers, staff would count cars in order to adjust the times for lane closures based on counting cars over 5-minute intervals. Other methods are to look at the Q sensors from the smart work zone. Rolling roadblocks were allowed in our contracts and were essential. This assisted with the large amounts of blasting that took place and would typically be 15 minutes or less. Did they ever run over? Yes. Not on purpose, but sometimes they would run over. Automated speed limit signs worked well, reducing the average speed through the construction zone 10 miles per hour. We did also utilize a tow vehicle over the past 4 years because of the lack of shoulders in some of the work zones. It is a great idea in conception, but in reality, we paid a large price with minimal hookups. So it's something I wouldn't necessarily support for future contracts. What did work in tight situations, where there was an inadequate shoulder for breakdowns, is the use of emergency pull-offs that were added to the latter projects. These areas provided a safe place to pull over and also served a second purpose as a controlled access point for our contractors' entry to the worksite. Critical sections were an issue. It's just funny how they never show up where you need them for the temporary stuff. Solar lighting was used on one of our projects that had a really tight TCP phase. The 93 team decided to order lighting, and the contractor came back with solar as an option. The use in this situation worked well and should be considered in the future. Smart work zones? I'll leave that up to you to decide. It's a huge cost. I would recommend that all contractor-supplied boards be capable of the remote operation, though. So here's a picture of an emergency pull-off. If you look closely, you will see the solar lighting. High-speed and low-speed shoulders are 2 feet. This made a good location for the use of the pull-off. We also had a tow vehicle on standby for peak commuter hours. Otherwise, if a vehicle broke down, we would only have 1 lane through this. We cannot have a lessons learned without revisiting our environmental issues along the corridor. Now that the work is finished, I can peacefully sleep during a rainstorm and not be worried what I wake up to. Many of these strategies you see here now are used across the state at various degrees. It took a while to figure out how to incorporate these into our projects. I like this slide because it demonstrates a bunch of strategies being used in this area. Water from the entire site is being pumped to this treatment pond. In the background, you'll see another pump and flock system set up. We used environmental sheeting to protect the wetlands, and we have a treatment swale along the sheets. In the foreground, you can also see a 6-inch PVC pipe that we would use in the winter as a clean water bypass when turbidity levels were low. All discharges from the flock system or pond overflow were monitored as they entered the mixing zone. Here you see the use of bonded fiber matrix, which was extensively used along the corridor. Early on, we used the old specification of hay mulch and tack, until we realized that we were not getting the performance that we really needed from this application. So we now use BFM extensively along the corridor. Sometimes you might see FRM or SMM called for in your projects, but they are essentially the same product with different concentrations of guar, which is the binding agent they all use. During the initial I-93 projects, the department was not required to submit erosion control plans to DES for review and comment. Because of this, DES wanted a more active role in the project. As an outcome of the DOT-DES monthly meetings, the department agreed to provide an erosion control plan to DES prior to construction, And along with that is the strategy sheet you see here. Other important items that came from our monthly meetings with DES included approval for flocculants and mixing zones. All of these items took a lot of negotiation. Here's a copy of the erosion control strategies that were initially developed for I-93 and now are used statewide. I believe now it is part of our erosion control plan that is sent to DES prior to construction and is the basis for our SWIP creation and implementation. There was a time when I thought the I-93 widening would not happen because of the erosion control issues. So what did it cost us to build I-93? As you can see here, prior to 2008, the department was typically spending between 0.5% and 1% of the project cost on erosion control items. That cost spiked around 2010 and 11 with all the rain that we had during that period, and costs were running around 8% of the overall project. Based on the strategies we developed and talked about previously, a long-term goal was to bring that cost down to 5%. To date, we spent around $28.7 million on erosion control items on the whole corridor, which I think is reasonable. Going forward, I think 5% is a good number to anticipate for erosion control items on major projects. Smaller projects with less environmental impacts, probably could bring it in around 2%. On the corridor, we had issues with our ponds if they were in blasted ledge. Even though we used the material specified for the impervious layer, water would eventually find the seams in the ledge and run through them. Also, cutoff walls for outlet pipes needed to be beefed up. We needed to excavate trenches wide enough to find the solid rock to pour against. Basins near wetlands could also be an issue, especially with fluctuating water tables. If a basin had a PVC liner, occasionally air bubbles would develop under the liner with a fluctuating seasonal water table, making for a nice turtle perch. And finally, make sure your basins aren't built on old ledge fills, because believe it or not, it happened, and we essentially had to reconstruct the whole basin. Here is the I-93 blasting fact sheet that Materials and Research and the Construction Bureau developed back in the early days of blasting along the corridor. The information proved useful in explaining the effects of blasting to concerned project abutters. The department has now adopted its use statewide and can be found on the website. Also not shown, the blasting BMPs that were developed on I-93 over the past 10 years and are now included in the 2003 specification for blasting as a BMPs the contractors must follow. Why is this important to follow good procedures when using explosives? Because we sample groundwater for contaminants. In order to be in compliance with the alteration in terrain permit, the department has a groundwater monitoring program for any site that has over 5,000 cubic yards of blasting. This is to quickly identify any problems concerning blasting operations. As you know, there is the potential to release nitrates into the water table because of incomplete detonation or poor practices loading holes. Early on, we drilled our own wells to monitor the blasting operations. Unfortunately, they were placed too close to the work area, and so we started to sample project abutters instead, as this was more reflective of what was really happening to the environment. The department typically performed extended testing at the beginning and end of each project and sampled for 17 different parameters, including the iron, arsenic, and hydrocarbons, etc. After the initial baseline sampling, the department tested monthly for nitrates, nitrite, and ammonia, as these are typically byproducts from blasting.
This was a large project with a complex design effort. Projects overlapped, not only with the work but with traffic control phasing, so this had to be very well thought out. Trying to have one design consultant perform all the designs would have been a monumental task. With this in mind, a project implementation plan was created. It highlighted what needed to be built first to address the areas of most concern relative to safety, congestion, and infrastructure. This plan created the sequencing for the early action, mainline priorities, and capacity improvement projects. The final design effort was split between two major design teams, a southern team and a northern team, to ensure availability of adequate resources to meet the ambitious schedule. The designs were planned to meet the construction schedule and the financial plan. There were two other contracts, the 13933A project, which was designed by a separate design firm, and the 14633J project, which was designed in-house. The design process was a team approach. However, dedicated staff like the quarter-wide supervisor for construction, J. Levine, were instrumental to the success of the project. It gave design a dedicated person to bounce ideas off of. Responses were timely and helpful, and all responses were consistent, making the designs more consistent. This overall corridor supervisor was available throughout the design and construction process and in developing the construction contract packaging and traffic control plans. This included associated phasing, detailed construction schedules, and very specific phasing timelines. Another key role was the DOT design consultant coordinator, Dan Primo. Having one main point of contact for all consultants and work on the corridor functioned very well to ensure consistency and efficient management of all aspects of final design and coordination. Specific procedures were employed to keep the team informed and on task, such as monthly team meetings, over-the-shoulder reviews, and tracking outstanding issues. Monthly project team coordination meetings were instrumental in the management of these corridor improvements. Each consultant team, as well as each DOT bureau, provided a status update and discussed issues, critical path items, and outstanding items. This kept everyone focused and up to date on the overall and specific project action items and schedules. Special committees were also established and maintained to guide the design and inform local entities of many items such as incident management, upcoming project schedules, and traffic control phasing changes. Incident management. Through the overall corridor, a TMP was developed. The incident management work group was established and met monthly to develop project needs early on to be sure that we had addressed everyone's concerns. This transitioned to a technical steering committee during construction that included individuals from the towns, city, emergency response, Massachusetts, the police, FHWA, and the list goes on. This involvement with the communities and the incident responders facilitated a successful corridor improvement program that surpassed everyone's initial expectations. Transportation Management Plan. Through the overall TMP development, at the beginning of the final design phase of improvements, a TMP work group was established. We met monthly to discuss specific topics and issues and ensure that current traffic operations and ongoing construction was progressing smoothly, and proper planning for upcoming efforts and elements associated with the overall corridor improvements were considered and addressed as needed. This proved to be helpful to keep everyone informed and provided useful feedback to everyone in the group as the corridor work, design, and construction progressed. Throughout all communities, meetings, and submissions, there was a high level of communication which aided in the minimized review times, minimized changes, and helped to control scope creep and cost. Utility relocations are often a lag at the start of construction. The utilities don't want to move if we aren't going to build the project, and who can blame them? Knowing the large amount of utilities on the corridor, we needed to get this going smoothly. NHDOT and their consultants coordinated with the utility companies on both a corridor-wide and a project-specific basis on critical path utility relocation issues. Innovative measures were evaluated and considered. The department also advanced design modifications to avoid utility relocations when possible. This ultimately saved time and reduced the overall cost of the project. The lesson: identify the risk and try to remove it or make it less of a risk. Utility delays, both in obtaining critical information needed for the design and in-field relocations during construction, are a critical issue in NHDOT construction projects. A number of efforts were pursued to address this. NHDOT employed subsurface utility engineering (SUE) services for the first time on this project to secure better information for design purposes and to minimize construction delays due to unexpected utility conflicts.